Welcome to EarthSky's Sun News of the Week. I'm Deborah Byrd, and I'm here with Dr. C. Alex Young, who is a heliophysicist at NASA Goddard Space Flight Center in Greenbelt, Maryland. And Alex is also a co-author of our daily Sun News post at earthsky.org. Alex, what a night last night.
It was amazing. It was amazing. I'm actually coming back from a late night trip with my wife, Linda. We got to see a good portion of the show last night, and it was fantastic.
Oh, and so tell us, what kind of a show was it? Tell
It was a
everybody.
it was an rural showcase. We got to see Aurora all the way down in Maryland, in Western Maryland, which is not the normal place to see Aurora.
Yes, and I have a picture here, which I am about to share, of the aurora that you saw. And this was taken by Linda Shank, who happens to be married to you, your better half.
Sure.
Yeah. And hi, Linda. And we have a number of beautiful images from all over. So it wasn't just Linda and Alex who saw this. People all around the world saw this. It was amazing. So I'm going to just click over now to the next slide. This one is from Alberta, Canada. And typically you see these auroras really far north. But last night, the strong was so strong, it got up to a G4 geomagnetic strong, which is just one notch below a G5, which is the strongest they can be. So it wasn't as strong as it can possibly be, but it was pretty darn strong and kind of amazing the way it just went all around. So here's the United Kingdom, saw this beautiful display. Here is an image from our own Marcy Curran, who was in Wyoming. You can see the constellation Cassiopeia in this one. And we did see a lot of reds in these auroras. Now we've gone all the way down to Arizona. This is not just Arizona, but this is southern Arizona. This is in Tucson. And Elliot Herman, who is a frequent contributor to EarthSky community photos, put this on our community photo page. In fact, most of the images that we're showing here are from EarthSky community members. And Elliot told us that this was a once in a lifetime photo for him because, wow, to see an auroral display this good in southern Arizona, that's pretty darned amazing. But it didn't stop there. It kept on going into Mexico. People in Mexico saw these auroras. And in the Bahamas. So it was a pretty amazing night for auroras. And looks like Alex is having some problems connecting. He was actually trying to connect from the parking lot of a McDonald's. So I don't know if Alex is going to be back or not, but I'm just going to plow onward here. So what happened to cause this auroral display? So for one thing, the sun is at the peak of its 11-year cycle right now. And that means we've got a really active sun. So this is an image from one of the sun observing spacecraft. You can see that the sun itself is covered by an occulting disk. And they do that so that you can see things around the sun. So that in the first part of this animation, not this part, but the part you're about to see, the red part, you'll see that it explodes around the sun. Boom, just then. We'll let it run through one more time. That's called a halo CME. And when we see something like that happen, we know that there might be a coronal mass ejection on its way to Earth. So that's what happened here. We saw this halo CME, and I believe this was the X flare that was from, it kind of straddled the 8th and 9th of October this week. So, so it, oh, there's Alex. Hey, Alex. I'm all the way on talking about the X flare that caused all this. Hi.
Hey, can y'all see me?
We can see you.
Okay, switching from an iPad to a phone. I think it's a newer phone, so let's hope the connection's a little better.
Good. All right. Okay. So we have flipped through all the Aurora slides and tell us your experience. Let's go back a little and talk about what happened. I'm going to go all the way back to that one in Maryland. Well, let's look at this one in Arizona. So this was such an amazing event.
Okay.
So what happened? Tell us to make this such an amazing event.
Well, what happened was that this eruption from the sun associated with that X flare was in a perfect situation. So it came from right near the center of the solar disk. So that means that it basically, if there's nothing else to disturb it, it comes straight towards us. There were other factors, like there were no other CMEs, there was no solar wind to deflect it, because sometimes those things can be deflected. So basically, we were hit at Earth by a direct shot of all of this solar material and magnetic field, and it slams into Earth's magnetic field and just kind of rings it like a bell. And the stronger that ringing is, the more electrical currents are generated in the upper atmosphere, and voila, they excite oxygen and nitrogen, giving us the red and green and then sometimes blue, which give us the aurora. So that's what happened last night. But the storm was really strong. It was very fast. It had a shock wave in front of it, which was what hit us first. This is just like a sonic boom on a supersonic airplane. And then what we call the core, all the good stuff in the CME came after that initial shock wave. And the other aspect of what we saw, and scientists are still going to be kind of sorting through all this data, because there's a lot of data. Not all the data is in yet, but we saw that this CME passed the stereo A spacecraft before it got to Earth, and we got a glimpse of that this might be a really interesting event, and it sure enough was. Normally the auroral oval is kind of confined to near the poles. The magnetic poles are close to the geographic pole, um, and so if you're under this auroral oval, then you see the amazing aurora overhead. Okay, the really dynamic, kind of like looking at colored curtains. But what also happens is, because that aurora is happening so high, hundreds of miles an hour, I mean, sorry, hundreds of miles above the surface of the Earth, that when you're at a distance, if you're close enough, you see the aurora on the horizon. So you see a glow, okay? But normally, you would only see that glow if you were, let's say, in maybe the northern US. But the stronger the storm, the farther south, the bigger the auroral oval came. And so, as you mentioned before, this was a G4 out of 5. Okay, so this was still a very strong storm. We actually rate that as a severe storm. A 5 would be called an extreme storm. And just for some reference, the storm that happened in May 10th and 11th was an extreme storm. Okay, that was really, really strong. But we were very close to that. We were very close to that line. I know the space weather analysts were kind of jumping up and down, really hoping that they were going to see the G5. But what that meant was, typically, um, from what I have learned, I haven't seen a ton of aurora, especially not in Maryland. I've seen it up in Iceland, but in Maryland, we don't typically see it. However, if the storms get to be about a G3, that's a good indication that you might see it as that far south. Um, But even in that case, we would probably just see it on the horizon. But what we saw, and actually Linda was the person that first noticed this, the aurora was in all directions where we were in
Wow.
Maryland. And so and it was moving, which meant that we were actually under part of the auroral oval. We weren't just
Wow.
seeing it on the horizon, because normally you would look northward. You'd look to the north to see it if it's just on the horizon. And so it was amazing. So one of the things that happens is these auroral ovals, or these aurora, when they create electrical currents in the upper atmosphere, those currents can be picked up on the ground, in the ground. Ground-based currents are not uncommon. If those currents are strong enough, and in fact, if the fluctuation is strong enough, it can actually knock out power grids.
Right.
And
And I just checked. It did not knock out any power grids that I saw.
right, so there were ground
I
currents.
haven't seen any
No,
news of power grids going out,
yeah,
despite the fact that New York
yeah,
City issued some kind of an emergency solar storm alert. Freaked everybody
right,
out, I'm
right.
sure, but their power did not
Well,
go out.
I'm looking at Justin Burke, who's a meteorologist in the Maryland area. And so he was looking at NOAA. NOAA does have something on their space weather site, the SWPC, Space Weather Prediction Center. And they do have a product that shows the ground currents. And so he was reporting the ground currents in the U.S. Midwest were near 5 volts per kilometer, which is more than 100 times the value that's normal when the sun is quiet. Um, Now, he did point out, because the very famous event in 1989 that knocked out the Quebec's power grid, these peaks that were measured were only 25% of what happened in 1989. And the other aspect to that is the power grids are much better prepared. The
Yes.
other thing that I can note is the May storms don't have any significant reports of power outages. Um, and I actually talked to an expert at Goddard in what are called geomagnetically induced currents. Okay, these are the things that can knock out power grids. And he said it's not just the strength of the storm, because the storm in May and even this one were very strong. It's how fast do those currents and the magnetic field fluctuate. It's the up and down, the change, that actually whether to the power. But if they're not fluctuating, then you're not going to have that problem. And he said that was not the case. So, and that's actually a really good how complicated this stuff is. I mean, we saw it was a strong storm. We saw that the aurora was really far south, just like in May, but we didn't have any power outages. So why did we not have that? Why was the CME not causing these fluctuations? And these are areas of ongoing research, because this is really complicated stuff.
It is really complicated stuff. But there is now, we are, as you said, we're much better prepared now than we were just a few decades ago. So a couple of months ago, I spoke
Hmm.
to Sean Dahl, who is a space weather forecaster at the Space Weather Prediction Center, and he told me that
Hmm.
when a solar storm of this magnitude occurs, they get on the phone. He called it a solar flare hotline. They get on the
Hmm.
phone with the three major power centers in the US, which is East, West, and Texas. Texas has its own, of course, where I am, woohoo, has
Oh
its
yeah.
own, yeah, has its own power center. And and that has really helped. So like he prepares them so that they can shed load so that they're not getting
Hmm.
too much in the system, which causes the system to go down. So,
Right. Right. And there
yeah.
are there are a lot of other, and I'm sure he talked about it. There are a lot of other uh,
Uh, uh-oh. Are we losing you?
that can cause these. So, it's a really interesting field.
It looks like Alex is having some connection issues. So let's see here. Let me stop sharing for a second. And I'm going to move. So that was last night. The big auroral display caused by the G4 geomagnetic storm that occurred in Earth's magnetic field, and auroras were seen just all across the U.S. northern states, and also, oh, Alex is back.
Okay, great. Yeah, so I got a couple of other things. So what did I miss? I'm sorry. McDonald's failed me.
McDonald's. Um, let's move on because we have one more thing to talk about here, and then Alex, we will let you go.
Okay.
And that is that you may have noticed when we showed the picture of the X flare that there's something else happening in that picture. And let me get to where I can show you that other thing that's happening. And that is this. So this is in the direction of the sun right now. It's not part of the sun, but it's in the direction of the sun. So that big white streak there is a comet. And that is a very unusual thing to see, a comet that bright near the sun. So this comet is called Comet A3, and it's going to be closest to the Earth tomorrow. We saw it in the morning sky, and we have so many beautiful images of this bright comet in the morning sky. We had been talking about it all through late September and early October. So if you did not see it in the morning sky, you've got an even better opportunity coming up. And that's because the comet's coming to the evening sky. And so that bright comet, Comet A3, is going to be in the west after sunset. And we looked all around this morning at our community photos and every place we could think of. I have not seen that anyone has seen this comet yet in the evening sky. So it was between us and the sun, or maybe it was, I don't know, probably wasn't between us. Maybe far side. I'm not sure if it was between us or on the far side. But at any rate, it was near the sun along our line of sight and closest to Earth tomorrow. But then starting about Monday, you might be able to see it in the western sky after sunset. So you want to look for it right after the sun sets. There's the planet Venus up there too, which this is not the planet Venus. It's not that very bright thing. Comets are distinctly not planet-like or not star-like. They have a tail, and watch for that. So Alex, you were going to tell us one more thing, and that is what people should do when they hear that there's an aurora alert out there.
Yeah, so I can't see you, but can you still see me?
I can see you.
Okay, good. Yeah, so I did not, I mean, I have to say, I did not do the best job planning. I didn't get out the door nearly as fast enough. So I missed the very beginning. But one of the things that Linda and I were talking about is what are the things you need to do to prepare? So there's a couple of kind of key things to keep an eye on, social media and see what's going on. But in terms of planning ahead, some of the key things are you want to look at the weather forecast. Clouds are definitely something you don't want, but you also want to go to places that are as dark as possible, as little street lights and city lights. And if in general, you want to start by looking to the north, but if you know the storm is going to be really strong, then if you know the storm is going to be really strong, then you may see it in all directions. But if it's only on the horizon, then you want to look to the north.
Right, and
Um,
Alex is talking about auroras here that you want to look to the north. We're still showing Alex, you can't see this, but we're still showing a picture of Comet A3, and everything you just said applies to the comet as well. Look on social media,
Absolutely.
see what other people are
Yeah.
seeing. Look
Yeah.
at your weather forecast. Make sure you've got a dark sky. So whether you're looking for auroras or you're looking for the comet, both of those things apply. Auroras mostly in the north, this comet in the west after sunset. So, Alex, sorry I interrupted you. Go ahead.
Oh no, that's okay. Yeah, I mean, the other thing is this also applies, as you said, to looking at comets or stars. Scout out the area. How are there trees? Can you see the horizon, for example? If because the horizon helps you to also figure out where you're looking. Um, so look on maps, figure out where's a good place. If you're going to go far, then you need to maybe get a hotel room or something like that. So those are things that you also want to plan ahead. Because in this case, one of the things that made it a little more difficult for me is that I didn't get there before dark to sort of plan out where I was going to be, which makes it harder. So
Oh,
again,
yeah.
yeah, do things ahead of time so you can get there before dark. You know where you want to go. And also,
Uh-oh, Alex,
a
we're
great
hearing you.
thing is having.
We were hearing you fade
You
out,
got
but now
me?
you're
You hear?
back. I gotcha.
Okay. Yeah. So one of the things that Linda pointed out to remind me is most of us have compasses on our phones, so those are really helpful. You can use the compass. The other thing is your phone. When we're talking about aurora, unless you're seeing really strong aurora, you're not going to be able to always see it with your eye. So using your phone's camera, looking through your phone, allows you to often see aurora that you normally couldn't see with your eye, especially red aurora. Our eyes are not as sensitive to red light, and the red aurora is going to be more common, especially the farther away you are, because the red aurora actually happens much higher up than the green aurora. It's still oxygen, but there's a lot less oxygen, which makes the red more prominent because you're looking much higher up. So the thing to think about is um, also remember that most cameras now you can control your exposure. You can also use the night mode, which allows you to set to maybe 3 or 10 seconds. We used a lot of 10-second settings. Um, so it's helpful to experiment with your phone ahead of time. This was also an experiment for me. I just got a new phone. Linda's really good with her phone. She's been taking some great astronomy, just nighttime sky pictures. We're going to go to Chile and see the southern sky. And so I'm trying to get used to using this phone to be able to take things like, pictures of the Milky Way and so on. So know your phone, know where you're going, make sure you know your skies and the kind of light that's around, and also the cloud cover. Those are kind of some of the key things. But
Yes.
these days, your phone is your best friend. So, and
That's an
even nowadays,
amazing
you got things
thing.
like, isn't it? Isn't
It's
it?
amazing. I mean, who
Yeah. I
knew
mean,
that
one of the
these
things
phones were
is
going to be so great for astronomy?
I know. I mean, now you have things like Star Walk and other apps on your phone. You can hold it up in the sky and it shows you what's there, which is really, really helpful and important. And I see, professional astronomers use these kind of things. It's not just for, the amateur folks.
Right. Well, Alex, we won't keep you any longer. Thank you so much for joining us today. And I hope we are at this moment putting together a gallery of images. We've just got so many beautiful images of last night's auroral display. So we hope you will come to EarthSky later today or tomorrow or over the weekend and check out the gallery of images. You've been watching EarthSky's Sun News of the Week with Dr. C. Alex Young, who is a heliophysicist at NASA Goddard Space Flight Center in Baltimore, Maryland. I'm Deborah Byrd, and we're almost done with our fall fundraiser, by the way. And I am just going to put this up here. Help support earthsky.org is the place to go if you want to contribute to our fall crowdfunder. EarthSky is funded largely by crowdfunding. So whatever you can do to help us out, help support earthsky.org. We would really appreciate that. We'll be back on Monday talking with Dr. David Ferranda about climate change cause and effect, and specifically about the two recent very devastating hurricanes that happened here in the U.S., Hurricane Helene and Hurricane Milton. So that'll be Monday at 12:15 Central or 17:15 UTC. We hope to see you then.